from the radiation to the atoms and in a particular molecule. What is happening? That is what he was knowing. Raman also knew this, and during his remark in his 1930 Nobel Prize address, he said, "The character of this scattered radiation enables us to obtain an insight into the ultimate structure of the scattering substance." I repeat, the character of the scattered radiation enables us to obtain an insight into the ultimate structure of the scattering substance. In the first 7 years of his discovery, the Raman effect was subject of more than 700 papers in the scientific literature. That means that everybody in the world started working on different liquids, and they were able to get the results. And mostly by the physicists who are using this technique to study vibration and rotation of molecules relating to this phenomenon, relating this to the molecular structure of the particular atoms and molecules. Then there is a remark by the biographer G. Venkatraman, who wrote the biography of Raman. He says there was a decline in the interest, and the first bloom of novelty has worn off. So everybody started working. 700 papers were published. Then what is there? What is there? There is nothing more to study about the Raman effect. So that is what we feel. Oh no, Raman's so much of fame was there, and there is nothing more. So chemists became interested in Raman effect as an analytical tool, because Raman had already told it is specific to the particular molecule or particular the solution what you're looking at. Hence, the method, the Raman effect, is specific to the particular sample what you're using. Hence, it can be used as an analytical tool. That's how James Hibbins' words, he says, the Raman effect became an adopted child of chemistry. You see, the switchover is from physics to chemistry now. So, chemistry people started using it as a analytical tool. By late 1930s, Raman effect had become the principal method of non-destructive chemical analysis. Please understand, you don't have to throw the chemical after doing the Raman studies. You can again use it. And it was analyzed for both organic and inorganic compounds. The unique spectrum of Raman scattered light for any particular substance serves as a fingerprint. This is a very important word here. The fingerprint means that for whatever you get for a particular substance, that is specific to the particular substance, and no other molecule will give such thing. Hence, it could be used for qualitative analysis, even in a mixture of materials. Further, the intensity of spectral lengths were related to the amount of the substance. That means that it is a concentration dependent study. Hence, it could also tell how much of the substance is present. Raman spectroscopy could be applied to not only to liquids but also for gases and solids. Now I am just listing. See what people studied at that time. To begin with is only the solution method. Now you see I am now extending it to gases and solids. And unlike any other analytical method, it could be applied easily to the analysis of aqueous solutions. If anything dissolves in water, then you will be able to study the material. Hence, it became a Sarvantariyami technique again, and giving information of what and how much is present in the plethora of samples. Anyway, again, the use of Raman spectroscopy as a basic analytical tool changed sharply after World War II, 1945. You will see in 1945, infrared spectroscopy was enhanced by the development of sensitive detectors and advances in electronics. Please remember, infrared also measures the vibrational and rotational motions of the molecules. Hence, infrared measurement became quickly and became routine operations. And again, Raman lost its importance because it required skilled operators and also darkroom facilities. Again, the Raman spectroscopy was revived only after the development of laser, and it was in 1960s. I'll be back. After discovering the Raman effect in 1928, Professor Raman was knighted by British government in India and received the Nobel Prize in Physics in 1930. So this, what I have used the word knighted, is one of the honors the British government used to give, and the Queen Elizabeth used to present this and put the medal to the person on his chest, on the coat. That is called as the Sir. It is that knighting is called as Sir. So we casual here colloquially we use Sir for all the teachers and others, but that is not to be used. The Sir was a knight award which is given to the people who have greatest achievements. That's how now C.V. Raman became Sir C.V. Raman. Please remember that. Till 1928, he was only Professor Raman. Then he became Sir C.V. Raman. The other person in our, as I remember, I know it was Sir M.V. So M. Professor, M. Mokshagundam Vishwesvaraya is the other person who got the Sir from the Queen. And recently, what I know is one of the cricketers, Sunil Gavaskar, got this award. I'm just telling you what is the specificity and the importance of the award. 3 years later, after getting this, Raman left Calcutta and came to Bangalore, where he served as the head of the Institute of Science, in which I am working now. There he continued his work on Raman effect and became interested in the structure of crystals, especially diamond. In 1934, he founded the Indian Academy of Science. Now, if you have come across the who founded the Indian Academy of Science, it is none other than Professor Sir V. Raman, and began publication of its proceedings. So Jagadish Mehra, one of the biographers, states, I read, educated entirely in India, Raman did outstanding work at a time when the small Indian community worked almost entirely in isolation and few made science as a career. I will repeat, educated entirely in India, Raman did outstanding work at a time when the small Indian community worked almost entirely in isolation and few made science a career. On the other day, I was just talking to one of the vice chancellors of Shivanadar University, Professor Rupamandari Ghosh. She was telling when she wanted to take up science as a career, she took the advice of an elderly person. That person told it seems this may be about 40 years back. It seems he told her, if you want to be an Indian, don't take science as a career. And again, at the same time, he also told, if you want to become a scientist, don't be an Indian. So you see, here is a great Indian who entirely got educated in India and able to do such a wonderful work and win the Nobel Prize. So it all depends on the mindset of how we look at the science. In fostering Indian science, Raman emerged as one of the heroes of Indian scientific renaissance. At that time, it was actually a Indian scientific renaissance which was happening, and Raman was the real hero of all this. But as Raman himself once said, outstanding investigators are claimed. They say, hey, he is an Indian, hey, he is a Britisher, he is an American. No, he says, yet in the truer sense, the scientists belong to the whole world. There is nothing like, confining themselves to a particular country. His positions and different institutions, what he did. Indian Finance Department as an Assistant Accountant General, I have already told you this. University of Calcutta, he was a professor. Banaras University, he was a professor. Indian Association for Cultivation of Science, he was a scientist. Then Indian Institute of Science, he was the director. Then later part, they started one more institute in his name, that is Raman Research Institute. Until his lifetime, he was the director of that institute. These are the different medals what I was talking to you about. Fellow of the Royal Society, 1924. Knight Bachelor, Sir C.V. Raman. It is 1929. Nobel Prize in Physics, 1930. Bharat Ratna Award, 1954. Lenin Peace Prize, 1957. If you want again, you can just have a look at the different awards what Professor Raman has got. Fellow of Royal Society, Knight Bachelor, Nobel Prize in Physics, Bharat Ratna, Lenin Peace Prize. Raman has authored 5 books: Molecular Diffraction of Light, 1922, The New Physics, 1951, Scientific Papers of Sir C.V. Raman, 2 volumes that have been produced, and finally, Why Sky is Blue. Doctoral students of Raman, you will be very interested to know, Vikram Sarabhai was his student, K.S. Krishnan was his co-worker all the time when he did the Raman effect. Professor G.N. Ramachandran was a famous crystallographer who later on became a very famous protein crystallographer. He started his crystallography work with Professor C.V. Raman. I don't know much about Dr. K.R. Ramanathan, but Professor S. Ramasheshan, of course, one of the famous spectroscopists. In fact, when I joined the institute, he was the director of the institute. Sisir Kumar Mitra, I don't have much information. Professor R.S. Krishnan, I have seen him because by the time I joined the institute, he had already retired. And of course, this is the S. Pancharatnam. He did a very good work and he found a very nice light diffraction experiment. But at the same time, it was also Berry who did this. That's why that particular work is called as